The global electricity use in the future low carbon world will be almost 3 times higher than today. The cost of electricity will define the total energy costs because of the massive electrification. Several pathways have been proposed for a low carbon energy future. A massive use of solar and wind power is a common feature in most pathways. Costs of solar power, wind power, and battery energy storage have decreased markedly over the last decade. The speculation is that the costs associated with solar and wind power will continue to drop rapidly. Many believe that the costs will drop to the extent that the cost of electricity in the future will be lower than today. But is that true? Can solar and wind power provide cheaper electricity in a decarbonized future compared to the current cost from fossil fuel power? Welcome to Key Facts about the journey to our future energy system. I'm your host, Tushar. In this episode, I'll use basic science to discuss the future cost of electricity. A realistic understanding of this topic is crucial for efficient planning and to avoid unpleasant surprises. But before moving ahead, a bit about my experience in the energy field. Before retiring, I led a team that was responsible for providing techno-economic guidance to the R&D programs in a multinational energy company. I have experience with developing, commercializing, and evaluating technologies in the energy field. Speculative assumptions are often used to discuss the future costs of electricity from solar and wind power. This has led to major confusion and misunderstandings. Such confusion can be avoided by focusing on basic science. What is basic science? It is undisputable knowledge that does not change with new findings. It does not involve speculative assumptions. We'll start by reviewing some background information. For a valid cost comparison of power technologies, their final product must be round-the-clock or 24/7 electricity. Solar and wind power cannot provide round-the-clock electricity on a standalone basis, but they can do so by using supporting options. For example, solar and wind power can provide round-the-clock electricity by including long-duration energy storage, backup power, and expanding the transmission network. These supporting options are costly. Such costs must be included for a valid comparison with fossil fuel power. Solar and wind power have one critical similarity with fossil fuel power. Basic science tells us that solar, wind, and fossil fuel power have the same primary source. The primary source for all three power technologies is solar energy. This is obvious for solar power, but what about wind power and fossil fuel power? Solar energy unevenly heats Earth, which leads to wind generation. Fossil fuels have formed from the remains of dead organisms, that is, from stored solar energy. Thus, solar, wind, and fossil fuel power technologies have the same source of primary energy. Also, they must provide the same final product, that is, round-the-clock electricity. The three power technologies have the same primary energy source and must deliver the same final product. This means that they are all part of the same basic energy system. This is important because it allows a direct comparison of the power technologies. So which power technology has a lower cost? The one that requires a lower resource intensity. The resource intensity of a power technology is the total resources it requires to provide round-the-clock electricity. Examples of resources include labor, materials, minerals, energy, land, and water. The power technologies need a range of resources in varying amounts. Fossil fuel power technologies require very large amounts of fuel, while solar and wind power, along with the supporting options, require far more materials and land. Obviously, the resource intensity of the technologies cannot be compared by simply adding up the resources. Only basic science can provide a valid comparison of the resource intensity of the power technologies. How? By considering the amount of help received from nature by each technology. More help from nature equals a lower resource intensity. For example, consider a flight from New York to London. Less time and fuel are required for the flight when there is a strong tailwind, that is, when there is a favorable wind direction. The favorable wind direction is help provided by nature. The resource intensity and thereby the cost is lower when nature provides large help. So the technology which receives large help from nature has a lower resource intensity. Nature provides different amount of help to the different power technologies. How to understand the relative help received by the power technologies? To do so, we must first consider the key challenges associated with their primary energy source, which is solar energy. Solar energy has two major challenges from the viewpoint of converting it to round the clock electricity. First, solar energy is extremely dilute. Because of its dilute nature, it is challenging to capture solar energy, which is a required step to convert it to electrical energy. Second, solar energy is intermittent. Therefore, providing round the clock electricity using solar energy is a critical challenge. A helping hand from nature can lower the level of challenge. The technology that receives higher help from nature will have a lower challenge and thereby a lower resource intensity. How much help is received by each technology? Let us first consider fossil fuel power. We know how fossil fuels were formed. The solar energy captured by ancient plants and organisms has been converted to fossil fuels. Nature has enabled this conversion by applying heat and pressure on the plants and organisms in the Earth's crust over millions of years. Specifically, nature has transformed dilute and intermittent solar energy into high energy density fossil fuels that are available for energy production round the clock. Based on any reasonable metric, fossil fuels are more than 1,000 times dense compared to solar energy. Nature has drastically lowered the resource intensity in case of fossil fuel technologies by easing the two critical challenges of solar energy. Because of the massive help from nature, fossil fuels are abundant, accessible, easy to transport, store, and convert to usable energy. Thus, nature has enabled an easy path to round-the-clock electricity for fossil fuel power. What about solar power? Solar energy is the direct source of energy for solar power. In case of solar power, nature does not help with the dilute nature and intermittency of solar energy. Consequently, solar power has a far more challenged path to round-the-clock electricity compared to fossil fuels. It requires a much higher resource intensity. This translates into a markedly higher cost for round-the-clock electricity. What about wind power? From basic science, we know that nature acts upon solar energy to generate wind. But wind is also very dilute and intermittent. So nature does not provide a substantial help to wind power. This means that the wind power also has far more difficult path to produce round-the-clock electricity compared to fossil fuels. It requires a much higher resource intensity. This translates into a markedly higher cost for round-the-clock electricity. A low-carbon world will require overbuilding of solar and wind power, large networks, and massive amount of long-duration energy storage. Long-duration storage, which can extend from days to weeks, is currently very expensive. For example, the upfront cost of solar power with just 12 hours energy storage is currently 5 times higher than natural gas power to provide the same amount of annual electricity. Technologies for long-duration energy storage are still in the demonstration stages. Costs of long-duration energy storage will decline with technology advances and higher deployment levels. But that will not change the basic conclusion. The cost of solar and wind to produce round-the-clock electricity will remain markedly higher than fossil fuel power. Why? Because they receive little to no help from nature and thereby have a much higher resource intensity. The cost cannot drop below the level defined by the resource intensity. The laws of nature dictate this. A high resource intensity is intrinsic to solar and wind power because of the lack of help from nature. Basic science dictates a markedly higher cost for electricity in a net zero world. Why is this topic so misunderstood? This is because of some recent studies that claim that solar and wind power will provide cheaper electricity than fossil fuels in a decarbonized future. These studies use several speculative assumptions in their estimation. For example, major assumptions are made about the required grid expansions and the future technology costs of solar, wind, and energy storage. These assumptions have large uncertainties. Also, the conclusions are very sensitive to these assumptions. Such studies are speculative and have an enormous potential for researcher bias. Most importantly, these studies ignore basic science. Over the decades, researchers have used many metrics to compare fossil fuel power with solar and wind power. Examples are materials intensity, fuel intensity, land use, and energy return on investment. Fossil fuels are superior based on some metrics, while solar and wind power on other metrics. Most studies have focused on isolated metrics and speculative assumptions. These studies have not used a basic science approach to compare the technologies. This major flaw of the studies has led to massive confusion. A holistic comparison is not possible by focusing on different isolated metrics. A comparison of the total resource intensity is crucial for holistic answers. Only basic science can be used to compare the total resource intensities of the different technologies. I'll wrap this episode with a quick summary. The different power technologies require a varied nature of resources such as materials, fuel, land, labor, and water. So the resource intensity for a power technology cannot be estimated by simply adding up the resources. A basic science approach is the key to compare the resource intensities and costs between fossil fuel power and solar and wind power. Basic science tells us that the electricity cost will be substantially higher in the future. This is because nature has provided massive help to fossil fuel power technologies. Such help is not available for solar and wind power. The quote from Albert Einstein is particularly relevant. Look deep into nature and then you will understand everything better. To sustainably address climate change, it is very important to develop a realistic understanding of all key aspects of energy. The information discussed in this episode is essential to plan efficiently and avoid unpleasant surprises. See you soon with another episode of Key Energy Facts.